Good morning, everybody. Uh, Today we're going to be talking about visualizing safety success, real-world applications of TrafxSAFE and video-based analytics. My name is Bismarck Navarro. I'm the project manager of the safety division here in Transoft. The first part, we're going to just explain a little bit of the agenda. So the first thing is what is TrafxSAFE. Then we're going to see some of our examples. We selected 5 different examples, real-life examples that we have done. One is traffic and safety analysis at intersections here in Portland. Another one is going to be before and after turning lane marking in Ontario, Canada. The other project is going to be a pedestrian crossing violations at tram stations in Arizona, here in the US. Then a very interesting project that was about cycling safety at intersections with the turning vehicles. This project was done in 5 states around the US. And a last one is going to be about the scooters, manual scooters like the kick scooters and e-scooters behavior. That one was done in the European Union. First of all, and just a little brief recap. So what is TrafxSAFE? It's a proactive video-based safety analysis product. It basically identifies potential issues before they become more serious. With that information, we can produce custom-based dashboards to the video analytics, prepare charts, graphs, and see the video clips and all the statistics that we have there. On that one, the idea is to observe safety-related events over time, like the trend. And we can do this in one shot, like basically 1 day up to 5 days, etc., different timings, or basically like a connected device that we can do monitoring 24/7. And the advantage of this is like you can own your own data. You can own also the raw data. If you decide to do analysis that are outside of our custom dashboards, you can do that as well. But I will leave that for another moment, or probably you already know that part, or you can ask some of us you can approach us. So here, let's go to some of the more fun stuff, which at the end is going to see what's going on with this. So what we did here is we're just doing the analysis just to make an example of how this data can be used. It's just the intersections here outside of the conference center here in Portland. This was collected last week by your friends of Quality Counts here from Oregon. And then the idea was just to analyze what was going on. There was a small conference as well. There were some folks here in this part. So just if we look at here, we have the camera view, and then just this image, just our traditional, I would say, image that we normally have produced over time, which is just to evaluate the different movements. Where you can see the vehicles going through, and then some of the cyclists are mixing these ones as well, and then the pedestrian crossing and the left turn movements that are just going in this one. So it has been more of a traditional approach over time, and then I would say it's interesting to see the heat maps and how the users are behaving. But then, with one of our recent features that we have now, is we can start evaluating by just some specific movements in the picture. For example, we can see only the pedestrian crossings in this case, and that image is just only the vulnerable users. There's a small filter in the top. I'm just filtering basically pedestrians and cyclists. We can see the cyclist just going through, and then the pedestrian just crossing in the sidewalk, and we can see how some of the pedestrians, they're just going around the intersection. They just don't respect always the crossing, and they start just going like in that image, just crossing before it. And the other one, I'm just basically here we're filtering the left turning movements with the pedestrians that are just coming from the east and the west, only in these side intersections. Something that I want to point out here, that additional to only detecting the users, like in this case the north side crosswalk, like in that one, if that's the case, we can start defining also the direction of the pedestrians or the cyclists or whoever, the user that you are basically identifying. Even if for any reason someone feels like there is a violation, that there are some cars going in the opposite direction, we can detect that as well. So I think it's the same one. Yeah, okay. So here, some other parts of our results. Just this is one is just to see the average traffic. Here I'm just keeping only the pedestrian movements, just to see what was in which moment we were having more, let's say, movement or users going around. and we can see the timings. We can see the north side crosswalk around 1 p.m. is having like the high increase, which we can understand, people in the conference, and then lunchtime, everybody goes out, and especially taking that one. Then after that, they mix and mingle in the one from the south side. And here, the next image is just you want to see what's happening with some of the interactions. Like in this part, we have just a few, just to make this remark. It was only 1 day of data. Normally, we say we recommend 3 to 5 days, but here we're just for the rush and to have this ready for this conference, we only collect 1. And we only see a few of these interactions. In this case, we can start, and then another image that we have, I just want to point that out here, that these interactions are only below the site design reaction time, which is the recommended one is 1.5 seconds. These are only the interactions, the near misses that happen below 1.5 seconds. After that, we have also another bunch, but these are the ones that we consider a bit more, we need to pay more attention, because theoretically it's the time that the user has to react before something happens. But then we have for this other scatter plot, which here what we're doing here is we are letting the user know these interactions are happening, but also what's the speed of the other user, which most of the time is a vehicle. And we will say, like, even though these two interactions are quite close, are in the same time, around 1.3 seconds, one user vehicle is going at 22 miles per hour, the one is going at 30. These ones are going quite slow. The folks here in Portland, I would say they kind of respect the speed limit. But if this one was going at 50 miles per hour or something, if the other one is a pedestrian, maybe, I don't know, it will go to the hospital directly or will go somewhere else, because hitting at someone else. That's what we need to basically be checking here. Besides only seeing the interaction, what's happening? What could be the consequence of the other user hitting this one? So this is, I would say, like the general things, just like a brief summary of what we can get. I don't want to go into details because then it will take me like a bit longer here, and so to explain what we can do. But just to an example, the other camera was a side-mounted camera. Like I said, our friends from Quality Counts, they came, installed the camera one day, collect video for 24 hours, and then just give us the video. But the other one, this one is a camera from the municipality, from the city of Portland. We can use also that video feed, and they just provide us a couple of hours, and then we just analyze it. Just very quick, I'm just showing the trajectories here, the heat maps in that side, and here only and these are the heat maps, where most of the users basically with the safety interactions. But then, like I said, this is just more or less what we can do with what we present in the dashboard, but now just go to see other type of examples, how this can be used. I'm going out to the US now. Let's go to Canada. The Transoft is based on Canada, so I need to show something from there. So we have here this in Ontario. We have a before and after project. We have this big intersection. Yeah, I live in Montreal, so this one is getting big for me. So like 3 or 4 lanes per direction is like, okay, this is something now. So to collect everything with one camera, it gets a bit complicated. So we use one other feature that we have, which is a multi-camera. We install 2 cameras, basically one inside and the other one in the front of it, and we merge basically the trajectories. So we can evaluate the trajectories in one side and the other ones in the other side. Basically, these 2 cameras are facing each other. What they did, this in the municipality, they have the before, they have certain marking already, which I would say like is decent, but they wanted to evaluate this. They installed these median extensions, they define the line marking. I don't know how to call it, but basically they installed this treatment, and they want to see what happened if something changed having this versus having this. So then we just provide them the data, and they start evaluating the speed of the vehicles, of the turning vehicles. That was the focus, the turning vehicles, the left turn vehicles with the pedestrians. They start evaluating that, and they just came with their conclusions. If it works, if it doesn't work, should we put more money on those ones or not? Then go back to the US again. We did this cool project, I think 1.5 years ago. In your case, let's say, like I said, here we have the big intersection with 2 cameras. Another option is, let's get a one shot. And we can get everything now with one view, and we want to evaluate something different. The idea of this project was to evaluate the pedestrian crossing in the middle of the road. Are they doing violations to cross to the tram station, or are they going to walk there? I don't know, but if I was in Arizona with high temperature and I'm coming from here and they want me to walk there and to come here, I don't know if I was going to do that. But that's what they wanted to find out. So I have two views here, the other one, and we have another example for another intersections. So here, this is just one of let's say the classic results that we just provide. Okay, this just an intersection, this user is doing a light crossing violation. I'm just doing the zoom shot to this one, sorry, to this one here. Let me go, just to make it, just show it closer. There's a pedestrian, theoretically should be waiting, but the one was captured by this one. But okay, these are the normal trends that we obtain with the side-mounted camera. So what was the purpose of the drone one? It was this one. So we have these users, I think they were thinking the same as me. It's too hot, I'm not walking there, so I'm just crossing here. So in this case, now the city needs to act. Do I don't care about that, or I want to do something here? So now they have the data to start thinking, what can I do here? If I install basically mid-cross blocking, crossing, sorry. Then, another interesting point that we did, it was, again, the data was collected by quality counts, and it was in 5 states in the US. I mean, I'm a cyclist advocate, so I really love this project because it was to evaluate the different left turn movements and basically with cyclists to see if you have different type of treatments, how that will affect the interactions. So we have this heat map here. We have the bike paths in this case, and then just evaluating this one. This is one of the typical treatments. We have the median extension, we have this extension this side, and then just the marking crossing, like I was like here in Portland. That's not a picture from Portland, but it's close by. And then we have another one, other treatments. The vehicles, they just basically cross here, and to see how that is affecting them. So it was another of the projects, how this information can be used. And so, oh yeah, sorry, this one we have, and then we have the heat maps in that case. Just to see, like, we have the merge of the different users. Obviously, we obtain the same thing, the safety interaction numbers, the near misses, and some of the videos as well. And then, just to finish this part, we have another very cool project that we did in the European Union. It's basically scooters and e-scooters. They wanted to identify are the rule here is like this: the e-scooters, they need to go with the bike path, and the e-scooters, they can go basically crosswalk. The idea was in around 8 locations, they did that part. They wanted to evaluate that there were violations or not. So that's just to summarize what we do with it. And here we have just one example of, fortunately, it was e-scooter behaving properly. We're just going where they need to be. We have this guy here. Additionally, they want to evaluate that, how close they were to different users. But additionally, with this site, I would like to remark another feature that we have, which is privacy. The client, they say like, okay, I don't want to the free site identify anything, so we apply some blurry filters, and in case this one is blurry, and we can also just apply just black filters and everything. So this is just to summarize one of the projects that we did, and the different projects that we can be done, and thank you so much for your attention.